Hello everybody and welcome back to our review of the force of friction. Today we will return to a very familiar situation. We once again have our box on our table on our flat surface. And the box in this problem has a mass, and this mass is 10 kilograms. And this means we know immediately that the weight of the box, that is, the force of weight that the box exerts downward on the table, is 10 kilograms times g, the gravitational constant for acceleration due to gravity, which is 9.8 meters per second squared. So 10 times 9.8 is 98 newtons. Now, that means that the table exerts a force back upwards on the box due to Newton's third law, of magnitude also 98 newtons. And once again, this is our normal force. Now let's say that our coefficient of friction is 0.1. So this box is moving to the right. Coefficient of kinetic friction is 0.1. So to get the force of friction in the negative x direction, we just take 0.1 and multiply it by the normal force, 9.8 newtons. Excuse me, 98 newtons, to get 9.8 newtons for the force of friction. So this question asks, what pushing force in the positive x direction, to the right, would be required for the box to accelerate 1 meter per second squared? So if the overall acceleration of the box is 1 meter per second squared to the right, we know from Newton's laws that net force, is equal to mass times acceleration. If acceleration is 1 and the overall mass is 10, that means the net force on the box needs to be 10 newtons. So as of right now, we know that we have this new pushing force. We'll call it F sub p, p for push. And we know that the normal force and the gravitational force, the weight of the box, balance out. So therefore the net force must result from the difference between the pushing force and the force of friction. So we know that the net force must be 10 newtons. 10 newtons, that is, to the right. So to overcome the force of friction, we have F sub p, our pushing force, and we need to subtract 9.8 newtons, and this will give us our net force, 10 newtons. Isolating F sub p gives us our pushing force is equal to 19.8 newtons. This is the correct value for the necessary pushing force for the box to accelerate at 1 meter per second squared. Thank you for watching.